You've heard of BEDMAS before, and if not, we use this made-up word, BEDMAS, as a way to remember the order of operations in which math happens. Because mathematicians created an order of operations so that if I want you to do something and I give it to you to do it, you don't do it in a different order than Yeva, and then all of a sudden I get two different answers. So this order of operations is a way to have a set of rules so that when we have something to do, everybody's going to do it the same way and come up with the same answer. So we'll always do what's in brackets first. Then if there's any exponents, we'll do that next. Dividing and multiplying. And finally, the last thing's adding and subtracting. And you know where this is used a lot? Is if you win a contest. Have you ever won a contest? And they say, you just won a contest, but you have to answer a skill testing question in order to get your prize.
My mom is hilarious.
Oh yeah? She gets mad at them?
Because she does, yeah, she can't do it. So
She can't do the order of and it's always an order of operations question. They say, can you solve this question? They've been getting easier, I noticed. The last one I had to do, they broke it down one line at a time. You just say, can you add 1 plus 5? And then it said, divide by 2.
Oh, yes,
Like,
I've seen that.
so they, I guess too many people were getting the order of operations wrong, that they started taking it off of the skill testing questions. Why did they do that?
Make it easier.
But no, but why do
Oh,
they have,
that's-
like, why? They don't have to have a skill testing question, or do they? Is there some
Oh.
legal? Must be some legal thing. I don't know. Anyways. Skill testing questions often involve order of operations. So what'll happen is you'll have a question like this. And in this question, if we write out BEDMAS, and we look at all the things that I see in this question. Do you see brackets in this question? Absolutely. Do I see an exponent? Yeah, that little 2, that's an exponent. I see adding, and I see subtracting. So these are things that I see in the question. And if I'm going through those check marks, well, I need to do the brackets first. And as you get better at order of operations, you might do multiple things first for yourself, but I'm going to do things one at a time for right now. Okay? So the first thing in that I see is brackets. I have brackets, so I have to do whatever is inside the brackets first. Do I have anything to do inside the brackets? Yes. I have 3 minus 6. So again, now we're going to think about our integers. You guys did a good job on that on the boards the other day. If you were on your number line and you were at 3, subtract would mean you go to your left. If you go left 6, where would we end up?
Minus 3.
Minus 3. Excellent. So now I can replace this as negative 3. And mathematicians with negative numbers, sometimes we put, like, I don't know, or like scared negative numbers are going to run away. I'm not sure why this is such the case, but we often keep a negative number in brackets to start with. So I just changed the 3 minus 6 to negative 3. I'm going to write everything else exactly as it was. So technically, I still have brackets, but when I look in those brackets now, it's just holding a number. There's no math right now to do in the brackets. And the first step I just like, if you're like breathed in and there's like this, I guess this tiny speck of dust somewhere in the air, it went right in the back. Anyways, I think I'll be okay. The first step, we actually had math to do in the brackets. And now the brackets are just holding the number. So when looking at my check marks now, the bracket 1, wow, that's a huge eraser. Bracket 1 is technically gone. My exponent, though, is still there. So now I'm going to deal with my exponent. 2 squared. Remember, exponents mean repeated multiplication. So 2 squared is, the base is 2, and you're going to multiply it by itself 2 times. So it'll be 2 times 2. So I still have this minus 3, and now this 2 squared will be 4. And I go in my list, and now I have successfully done my exponents. I look what's left. I actually don't have, you see the subtracting went away because it was inside the brackets and we did that already. The only thing left I have now is adding, and now we're back to our number line. If you started at -3, adding 4 would move to your right. So I'm at -3 on my number line. I add 4, and I get 1. And that's our final answer. Sometimes when we do these questions, we put like equal signs along the way to say the original one was equal to this one, is equal to this one, is equal to 1. That's our order of operations and how it works. Right? And as you get better at it, right? Like if I ask Mr. Shirk to do this first one, he might do the -3 and then say, I know I can do the exponent next right away, and he'd write +4 right away. Sometimes that can happen. Sometimes you can write and do a little bit more mental math in your head as you get more comfortable, as long as we're doing the operations in the right order. Okay, so if I look at this one, and I think about BEDMAS, and I just start seeing what I see. Do I see some brackets? I'm going to put a check mark there, and then I'm going to look, do I have any math to do, or is it just holding a number? And in this case, it is just holding a number. So I can uncheck that. Okay, so I can actually, wow, that was a big eraser. I can erase that check mark because the B part is just holding a number. I'm going to look through, do I have any exponents? No. Do I have multiplication? A division? No, but I have multiplication, and I see an adding. So this is what I have right now. Okay? We talked about this a little bit before. We're going to start seeing a dot for multiplication more and more instead of the X like we used to have. Because we're going to start using the X in some algebra stuff later. So they sort of switch. Well, that might get confusing if you're using an X for 2 different things, so we start switching to a dot. So the dot also means multiplication. And I have 2 different multiplications, so I can do both of them. And again, it's going to involve some integers. 5 times 3, you guys were amazing at that. Oh, did you guys find any, did anybody find an app yet that practices your multiplication? Okay.
Okay.
I'm gonna get off topic on multiplication once we're done this question because it's so important. But yeah, okay. I'll get off topic. We'll finish the question, please. 5 times 3, 15. Here you have 4 times 8. Well, technically you have -4 times 8. Whenever I'm multiplying, so I'm going to keep my plus sign there because it's still there, but 4 times 8, I'll just do the numbers first. 4 times 8 is 32. That's the one for me as a kid. That was one of my harder ones. And then we have to deal with the negatives and positives later. So in integers, if you have a negative number times a positive number, is the answer going to be positive or is the answer going to be negative? Negative. Excellent. So then I would do the 4 times 8 first, then I'd add my negative there. And once again, I put it in brackets because I'm holding that number, especially if it's a negative number. So now when I go to my list of things, I have done the multiplication. All that's left is the adding. And this one I'm going to draw a number line up because I'm going to want you to do it with mental math. I'm going to have 0. I'm going to pretend, I'm not going to do all the ticky marks. I'm just going to label that 15 is here. And I want to go plus, normally goes to the right, but plus a negative, negative says switch directions. So if normally you would be going plus to the right, plus a negative says switch directions. You're actually going to go to the left. And I need to go back 32. I'm going to subtract 32. But I'm going to try to do this a little bit easier. I'm going to first get to 0. If I get to 0 first, I would do 15 away first.
I had to do that because I couldn't figure it
You got to figure it out.
Yeah.
It's hard, right? So I'm going to do 15. Now, my question for you guys is what's this other jump? And this number and this number have to make 32. You did 15 already. The negative just says the direction I'm going. I'm going backwards. I went 15 already. How many more would I need to go to make 32 in total? Adding and subtracting skills.
Could be negative 17.
It'd be another 17, so I can show it here as negative 17. And if you do it this way, this math is really easy. If you're at 0 and go back negative 17, can you see that it's pretty obvious you will be at negative 17? Rather than trying to do it all at once, do it in an easier section. Right? Get back to 0. If this 15 plus what is 32 is hard for you, do it in smaller sections. Do like, it's not bad to say, well, maybe I'll jump 15 first, that'll get me to 30, and then jump 2 more. You could do that as well. You have some options with your numbers. Play around with it, think about things, and see what is easier, what is harder. Okay. Now, I said I'd get off topic. I really want to get off topic about multiplication. You guys need to find something. Either you could practice on your own, but I'm going to tell you, you need to practice your times table lots, a little bit every day. Do something. Now, one of the things that sometimes comes up with times tables is that after you do it for a bit, sometimes we get overconfident, like, yeah, I got this, and then we stop practicing, and then when it comes to a quiz or a test, when you get a little bit nervous, you all of a sudden don't remember something. So sometimes, I don't know, sometimes it's a little bit more fun if you have a challenge. So I showed you, and I'll show it to you again, I showed you one thing that I thought was kind of cool yesterday that practices your 10 times table. So let's say I'm going to do 8 the dot times 300, that's a 2, 257. Okay? And then I said, if you wanted to do this in your head, you could do 8 times 2, that's 16. And I showed you yesterday, write it on a bit of a diagonal. And then 8 times 5, that's 40, write it on a bit of a diagonal. And 8 times 7, that's 56, write that on a bit of a diagonal. And then slice your numbers this way. And if you add them up, 6, 5, 4 plus 6 is 10, that means the 1 would carry over here. You can then take out your calculator and check. And sure enough, 8 times 257 is 2056. And it's kind of cool that you can do it that way. Sometimes I even have, if you're doing 8 times this, I've even shown students that make 3 boxes, join the diagonals there on the boxes. I did a different color. Then it might work out nice. Here's 16, here's my 40, here's my 56. Because sometimes when you write them on diagonals, you might not know where to draw the lines. What's cool about this is that prior to maybe this year, someone said, are you confident in multiplying something like 8 times 257? You would have said, no, not at all. But now, if you're practicing your times table, you have a paper up and you try this, and someone comes by, because this is the thing that it's too bad, but sometimes we feel bad when we don't know, like this is normal human nature. If you feel like you don't know something well, you kind of feel bad about it. And if someone comes by and you're like practicing your 10 times table and they say, what are you doing? You're like, I would probably be like, I'm nothing. Or like, I'm not going to tell you I'm practicing my 10 times table, because then you might say, well, you don't know it, and then you feel bad, and then it's all like this. And so then you avoid those things, and what happens, then you don't know your times table, and things get worse. Right? If you were doing this on a piece of paper, you are, like, technically, you're practicing your times table.
Oh,
Right?
totally.
16, 40, and 56. You practice 3 of them right there. You add them up, you take out your calculator and check. And if someone comes by and you're saying, oh, I'm just doing some mental math, like 8 times 257, they'd be like, wow, that's like, seems like impressive math. And all of a sudden, you go from having to feel shy about not being impressive, and now it's like, wow, that's a little bit more impressive. So, I'm going to show you the next level.
17 years in math, I haven't seen that before.
I'm going to show you the next level. You'll like this, okay? I showed you just one digit. Let's do
13.
138 times by. How big a number do you want? Another 3-digit one?
342.
342. 3 numbers here, 3 numbers here. I'm going to make a big square. These 3 numbers, 1, 2, 3, 138. These 3 numbers, 342. We draw, here's our diagonals. What the heck? Okay, now as far as timetables go, you just have to fill in each blue square. Can you do 1 times 3? Yeah, I hope so. Okay. 0 and 3. What's 1 times 4? 4. So I'd write a 0 and a 4. 1 times 2 is 2. 0 and a 2. Okay. What about 3 times 3?
0.
That's 9. So I'll write a 0 and a 9. What about 3 times 4? 12. 1 and a 2. 3 times 2? 6. 0 and a 6. 8 times 3? 24. 2 and a 4. 8 times 4, 3 and a 2, 32. 8 times 2, 16. Pick on a different color. Start here in the bottom. 6. 6 plus 1 plus 2, 9. 2 plus 2 is 4, plus 3 is 7, plus 4, 11. So we get 11, I'm going to have to put another 1 in this one, because it's over 10. Are you okay with that part? It's over 10. And then I have 1 plus 4 is 5, 6, 9 is 15, and 2 is 17. I carry over a 1 again. 1 plus 3, 4. What are the numbers that I'm left with? 4, 7, 1, 9, 6. Oh my goodness, I'm a little nervous. 342. Does it work?
It does.
That's pretty crazy. You just, like,
It's challenging everything I've learned.
what's crazy here is this looks impossible. And yet I would say the hardest one in here was 8 times 4. The hardest math I had to do was 8 times 4. I had to add, the biggest I ever added up to was 17. Well, I mean, that's pretty impressive, adding up to 17. I'm feeling pretty good about that. Sometimes I had to carry the 1s over, so whenever a column added up to more than 10, I carried a 1 over. When you do really big numbers, there's sometimes that, like, you add them up, it could get up to like 25 or something. You'd have to carry the 2 over.
Like,
Do you want to do another one?
It
Should we do it?
challenges everything I've learned. Because it's like, but yet it's still place value, but my brain can't get there, and it's so much easier.
So much easier than that.
So much easier. then remembering how,
Oh, yeah.
having to do the.
Yeah, well, learning
And
the
then put a
algorithm.
0. Okay, next line, then put a 0.
Yeah, it's crazy, eh?
But I'm trying to imagine, is that the same setup?
It eventually does the same thing. Now, technically, this you can, like, this is historical. You can find this on YouTube and on math stuff. But I was doing some research with a bunch of students on doing math stuff, and we're playing around with this. And the kid says, "Well, the kid said, let's see if we can do it for bigger numbers." And they came up with this, and it works beautiful. It's not on the internet anyway, and it works so nice. You want to try another one, just to see it? Okay. How? And you can go as big as you want. It just means you're doing more times table. But what number do you want to start with?
497.
497.
9 in there.
Okay. And who wants to pick another number? You don't want to pick a number? Pick any. Want to pick a number?
532.
532. This is going to be a big one. So I have 3 here and 3 here. So I make my square with 3 here and 3 here. So it's the same as last time, 3 by 3.
If
I mean,
it
if you had a 4 digit, you'd have 3 and 4.
If it were 2 and 2,
Same thing, just be the
2
smallest.
by 2,
Yeah. We can do a 2 by 2 after.
and then if it's single, you could do it that way.
Yes, and a single is also can make the squares, right? Like I showed you with the single one, it's kind of cool. If you make the squares, you for sure,
Oh, right.
you for sure don't, like I did it without the squares, but sometimes you might get lost. Squares kind of tell you have to fill in something. It's kind of nice that way. Now I'm going to switch colors and draw my diagonals right away. $497, 532.
Okay, but I'm gonna write it myself too.
You're gonna take out scrap paper. Now, as far as practicing your times table, okay, 2 things I like about this. One, this one practices 9 things on your times table. So that's pretty good for practicing your times table. You add it up in the end, and there's sort of a challenge here. Because you can check it with your calculator afterwards. If you got all 9 of them right, and you added right, your answer will be right. If you make a mistake, one mistake somewhere, your answer is going to be wrong. So it's a bit of a challenge. It's like, and challenges, I think, make learning fun. Right? If I give you work that's not challenging, you will be bored and not want to do it. If I give you stuff that's doable but also a little bit of a challenge, then you're more intrigued to want to try it. And the nice thing about these is you can make up your own. You can check them on your calculator after and see if you got them right. And it's basically times table. 4 times 5.
What if it's 3 numbers though?
What if it's, well, as soon as, you always only have 1 number per square. And none of your times table go over 100. Because the biggest one is 9 times 9. You're going to get to 81. So it's a good question. But if we set it up, it'll always fill in 2 numbers. So like 4 times 5, that's 20. 4 times 3, that's 12. 4 times 2, that's 8. Anytime there's just a single number, I put a 0 in. You're okay with that? 9 times 5, 45. 9 times 3, 27. 9 times 2, 18. 7 times 5, 35. 7 times 3, 21. 7 times 2, 14. Switch colors here. Start on the bottom. Add 4. 8 plus 1 plus 1 is 10, so I'm going to have to add another 1 to that one. 1 plus 8, 9. Plus 1, 10. 17. 17 and 2 is 19. 19 and 5, 24. So I put the 4 there and add the 2 to the next one. 2 plus 2 is 4. Plus 2 is 6. Plus 5 is 11. Plus 3 is 14. The 1 up there. 1 plus 1 is 2, plus 4 is 6, and then this one's just 2. And 264,404. Is it, did you check it?
Crazy. I got it. Oh, I didn't check it on my calendar.
Oh, Mr. Confident over there.
Well, I'm confident in you, so I know
It worked. It worked. Like,
that's pretty
Is-
awesome.
that is a crazy thing to multiply together. But just practice your times table. It's one of the reasons I said, if you know your 10 times table, you're set to do a whole bunch of stuff. And it's so powerful. If we get one of these numbers wrong in there, when you check your final answer, it's going to be wrong. And then that's the challenge. You're like, okay, now it's a puzzle. Where's my mistake? And when you get it, getting that answer, I don't know, I think that gives you a sense of some sort of accomplishment more than 2 times 3.
No.
What's 2 times 3?
6.
Do you feel very accomplished?
Uh-huh.
Okay, well that's, but I think you feel a little bit more accomplishment when you get that bigger number.
Yeah.
Okay? So, something if you can't find an app, right? Do this, right? Specifically, if you're ever having to do homework at home, right? It's never bad if do you have siblings? Older siblings? Okay? You pull out this and you say, I'm just practicing some mental math. And they're like, you did that quick without a calculator?
Yeah.
You're like, yeah. Okay? And if they say, well, how do you do that? You say, well, pay me $10. I'll show you. Make some money out
I
of it.
promise if you set that up in front of any one of your parents, they would be shocked that you did that.
And it's not hard.
No.
And it's
They'd
kind of,
also be like, gee, math has really changed.
yeah, well, nobody knows, like this, like I said, this isn't out there.
Yeah.
This,
But I mean, because they don't know that.
Yeah.
It's,
yeah, it's like,
they're like, what am I looking at?
just say, well, my teacher gave us a way to practice our times table that's kind of fun and kind of different. So, anyways, I got off topic. We were on order of operations. We were on bed math. So you can turn back to that question. If you forgot the method, I saved it in the video there. So you can come back to it. You're like, how did we do that again? And it works 2-digit numbers, 4-digit numbers. You want to do an 8-digit number, an 8-digit number, you're going to have a big square and a lot of things to fill, and the adding's going to get a little bit annoying because you have to add a lot of numbers, but it will work the same way. Okay, Ben Mass. This one's a little messed up. Do you see brackets? Do you see 2 different kinds of brackets? It's like, there's round brackets and, like, I'm going to put a double check mark beside the bracket thing because there's like double brackets in this one.
What's the difference?
Okay, we're going to talk about the difference in a second. We'll just go through our list first and then like, why is there a difference in brackets? Could there, what does it mean? We'll get to that. Is there any exponents? No. Do I see dividing? I see a dividing sign. Do I see a multiplication? No. I see an adding sign, even though it's in a bracket, so it might go away earlier because of the brackets. And I see subtract. So a really good question. Okay? Different brackets, do they mean different things? No. However, sometimes we use different brackets when we have more than one set of brackets. So in this case, the different brackets are kind of to help you, and I'll color code it to say this goes together as one set of brackets, and this goes together as another set of brackets. for me personally, when I'm writing questions with lots of brackets, sometimes if I were to rewrite this is what I would do. I like round brackets. But when I have brackets inside of brackets, I might change the size of the round bracket. Is it really obvious that the big ones go together and the little ones go together? So sometimes doing that. Because what happens when you have a round bracket like this is the start. And then, oh, another one started. And then when I close it, which one did I close? I closed this one, and then I closed the other one.
Wait, so what do you just do? After you do 7 minus 2, what do you do 3 plus whatever? I don't know.
Yes, excellent. So now, you can pick brackets and look inside. Let's say I pick the big brackets first. You pick the little brackets first. If I pick the big brackets first, now I have to do order of operations in my brackets. So I have to if I pick the big brackets, I'm like, I have to do BADMAS again. Should I do the adding, the subtracting, or the brackets? Oh, I should do the brackets, and then I should do the 7 minus 2 first. So in this question, the very first thing to do is the 7 minus 2. What is 7 minus 2? 5. There it is. And I successfully got rid of one of my brackets is gone because I did the math. I still have the other bracket. Now what do? I do the 3 plus 5. That's going to give me, what's 3 plus 5? 8. And since it's a positive number, I can just write 8. If it was a negative 8, I'd probably keep the brackets there just to hold it in place. Some people keep positive numbers. Like if you're like, I'm afraid my 8's going to run away, it's not wrong to put it in brackets, but it's not necessary. Now I've done my other bracket. What am I left with? I still have dividing. Hey, I no longer have the adding and subtracting. So I only have one thing left to do. When you only have one thing, really order of operations is very easy. That's the thing you have to do.
Just do that one thing.
What is 32 divided by 8? 4. Oh. Okay. I'm impressed with you guys. I love the fact that you're throwing numbers out there. You're already taking those risks. You think you know the answer, throw it out there. If you were like, I think I know the answer, but I'm not sure, and you throw it out there and it's wrong, that's not bad. Right? But it means that you're thinking about these things, you're getting involved, and that's going to help. At the end of the day, I want you guys to get better at your math skills because I know from my life experience that you're going to use it all the time. And if you have it, it's empowering. And if you don't, you feel like, ooh. Question?
If we say we have a test on that, right?
Yeah.
If we don't do it that way, will we do it if we don't do it your exact way as you're telling us,
If you follow BADMAS, you're going to be fine.
yeah, no, I'm not saying I'm not following, but that's the way you mark it down, what you.
Oh, if you don't do it step by step, if
Yeah.
you did, some of you will be like, I know 7 minus 2 is 5, I know 3 plus 5 is 8, and you go right to here right away, that's perfectly fine. Okay?
Keep in mind though, if you're wrong at the end, it's kind of hard to get part marks.
Right. If you I did it all in my head, and you write down 5, and that's all you got, I'm like, oh man, I can't give you anything for just writing down the wrong answer. It doesn't matter if it's close. Right?
But then you can get it wrong and write all that down, and
Yeah,
maybe
yeah.
Mr. JR sees, and then
Right.
all of a sudden you get half or a quarter mark or something.
So, when we're marking things, there's a couple of things that we're looking for. Okay? One, when we're marking things, do you get the idea? Are you doing the right order? Do you have the overall idea? But maybe you made a mistake in something little. Maybe that little thing was 32 divided by 8. For some reason you thought it was 6. Maybe that's your mistake. Then I'd be like, oh, you've got all the ideas are there. You made a mental math mistake. We all make mental math mistakes. So then that wouldn't cost you very much marks. Still not going to get full marks because you made a mistake, but Not gonna cost you a lot of marks. But if you all of a sudden do 32 divided by 3 first, then I'm like, you aren't getting the idea. That's gonna cost, like, as marking goes, that costs more marks. Alright. Then you don't have to, like, I'm writing this out right now. But as you get going, that's gonna be in your head. And probably what's gonna happen in your head is you're gonna go BEDMAS and you start with B, do I see brackets? And that's the only check, yeah, I'm gonna do it.
Yeah, you just do it right
You just
away.
like, as soon as I see brackets, I'm going to do it. So the first thing you would do is you'd rewrite everything else, 24 divided by 6 plus 9 minus 5. Cool.
It's funny because I used to teach a lot, like help a lot of students where I would underline what you're going to change.
Mm.
So in this case, I
So
would
you would
underline
show
9
this.
minus 5.
That's what I'm doing first,
And then everything else stays in its exact place.
right?
Wait, on this, since it's plus 4 and then you can't do 24 divided by 10, would you just do 2 then?
Okay. So you see what he said there? He said, like, you have to be careful because the number one thing that's going to get you in BEDMAS is that you want to do what's easiest. The easiest thing I see here is 6 plus 4. You said it was 10. That's the right answer for 6 plus 4. But according to BEDMAS, we got to be careful here, because now if I keep BEDMAS there and I go through, do I have brackets? No. Do I have exponents? No. Do I have dividing? Yes. I have to do that dividing before I do the adding. And we're tempted, like, sometimes I think math is all about temptations. It's like, give you something easy to look at, like to trick you into like, do this first, and then, I don't know, make you go off a cliff. So that's So we have to do the 24 divided by 6 and get
4.
that 4 first, and then you can do the 4 plus 4 and the answer is 8. If you did the 4 plus 6 early and got 10, 24 divided by 10 is technically a decimal, it's going to be 2.4, but you get the wrong answer, right? Only you haven't done any arithmetic wrong, you've just done order of operations wrong. So I think this is a great example because that temptation is there.
So you do 24 divided by 6 first. And
24 divided by 6 has to happen first because it's according to the BEDMAS at that step. I'll underline it. I like that idea, Mr. Shirk. This in BEDMAS is what has to happen first. And we did that and got this. And now you only have one thing, so it's easy after that to get our 4 plus 4. Right? Again, also asking those questions. Asking, why do you do that? Where does this come into place? Why can't I do this? Right? Those are good questions to ask because they also help us go, oh, yeah, I got excited about the math I could do. I could see 6 plus 4, I could see it's 10, and I skipped the BEDMAS thing, and then it caused me to get a wrong answer. Okay, BEDMAS again. Here we go. There's our BEDMAS. I see brackets. Is there any math to do in those brackets, or are they just holding numbers? They're just holding numbers, so I don't have to put a check mark beside brackets. Do I see exponents? No. Do I see dividing? Yes. And I like what Mr. Shirk, I can underline it. It's right there. Okay, there's my dividing. That's the first thing on my list. I have to do that first. So, times table. 54 divided by 6 means 6 times what is 54? 9. Excellent. 9 plus, and then we have 4, and negative 2, and negative 7. So when I go through, now I can, like this check mark would go away in my head, and I'd start again. Brackets, they're just holding numbers. No exponents, no dividing anymore. I do have multiplication. When brackets are touching each other, or when there's a number in front of brackets, I can add dots. Oh, I can add dots here but these three are all multiplied together. So I have to do, I'm gonna underline this, I have to do this multiplication next. So I'm still gonna have the 9, I'm still gonna get the plus. And now we have a triple multiplication. First of all, I would just do the numbers. I don't worry about the negatives and positives. What's 4 times 2 times 7? You can break it up. What's 4 times 2? 8. So now you have 8 times 7.
56.
56. I'm going to put it in brackets because I want to figure out, will it be plus 56 or minus 56?
Minus.
We have a plus 4 times a negative times another negative. Okay? If you just do two of them first, positive times negative is
It would be negative.
negative. So these two, positive times, this will be negative. And then negative times negative
Positive.
is positive. You don't have to write that plus sign there. But it just shows me I thought about it, I figured it out. And now I have 9 plus 56.
64.
Close.
Wait.
65.
65. And again, you can use that if you have 9 plus 56. In my brain, this is what I would do. I would actually start at the 56. I start at the bigger one. I need to add 9, but I find it's easier if I add to 4, I'm going to get to 60. How much more do I have to add to make sure that I've added 9? I would have to add 5 more. 65. Sometimes if we do, when we're adding, if we jump to a multiple of 10, like 60, 70, 80, one of those numbers, if we jump there, and then say, okay, I've done 4 of them, how much more do I have to add 9? I have to add 5 more, you get 65. Okay? So that is our final answer there. All right, we'll leave place value for next class.
Center button.
Go here.